Hi, my name is Andrea. This is my week 4 video assignment discussing the immune system and what kind of obstacles a microbe would have to overcome to get into our system. Um, and so this would involve something like a splinter or something entering through a wound on our hand, because the first obstacle a microbe would face would be the skin. And the skin is made to protect us because of its construction. It's very tough and, it's tightly packed, fibrous connective tissue that would be hard to penetrate. So it would take something like a splinter or, something would have to puncture that skin and get past, the rough environment of it. It's very dry. It's constantly being shed and taking microbes with it. So first it would have to do that. So it would take an open wound or a splinter or something to surpass that. The next part, and these are parts of the innate immune response, which means it's non-specific. It would act the same towards any type of microbe that was trying to invade. These are not made for specific antigens. So the next part that a microbe would have to overcome on areas of our body that are not covered by skin, so like our mouth, which leads to our GI tract, or our nose, which leads to the respiratory tract. There's also the genitourinary system. We have mucous membranes there. And these areas are lined and they're constantly supplied with mucus that can wash away any invading microbes. These systems also have ways of moving microbes out of the body through like cilia, or like in the digestive system, there's contractions that will move stuff towards an exit of the body to get these invading microbes out. And we also have several substances, antimicrobial substances, on our skin that can interfere with any invading microbes. Things like lysozymes that can interfere with the membranes of the invading microbe. And also there's other substances that can bind to important nutrients that any invading microbe would need, like iron. Lactoferrin binds to all the iron and in a way that would like starve any additional or invading microbes, making it very difficult for them to multiply or grow. And then we also have our normal microbiome that kind of lives on and with us. It's part of healthy human beings. And these protect us by providing competition for invading microbes, for space, for nutrients. They also, some produce toxic substances that that can kill invading microbes. And there's also like parts of the innate immune response. An invading bacteria would have to get past the inflammation process. So what that's going to do is it's going to send local blood vessels will dilate in that area, sending more blood to that wound on your hand, and that will cause the swelling and the redness and the warm. That the area of the wound will feel warm to the touch, and this brings white blood cells to the site, neutrophils and monocytes, which later become the macrophages that perform phagocytosis. And the clotting that happens also seals off that area. So if there were any microbes that entered through that wound, there's a clot now stopping those from moving further into the blood system. So that's another thing. And there's also a fever response. The higher temp inhibits growth of bacteria. There's also the complement system. And what these are proteins kind of floating around, activated by an invading microbe that cause a cascade of reactions that ultimately end in the death of the invading microbe. And at the same time, we have our adaptive immune system. And how that differentiates is that these are cells that B cells and T cells, and these are made tailored specifically to a certain antigen, a certain invader. And so there's the humoral, which involves B cells, the cell-mediated, which involves T cells. The humoral, the B cells can recognize invaders in our blood, in our tissue, just out there floating by themselves. The T cells they can only recognize the invaders once it's inside a host cell. So what'll happen is B cells are activated by an invader. They will differentiate into plasma cells, which then create the antibodies needed to fight the infection. And at the same time, there's also memory cells being created, which will remember this specific antigen. So if there's another exposure later on, these cells are kind of primed and ready to go, ready to fight in a much stronger and efficient way. The T cells, there's helper cells, and then there's the cytotoxic T cells. The helper cells do a lot of things. They communicate with the B cells. They can encourage the growth of these macrophages, make them stronger. They deliver cytokines, which induce changes in cells that make them easily recognized to be destroyed. And the cytotoxic T cells are the ones that actually destroy the cell by bringing about apoptosis. So an invading bacteria would have a lot of things to fight against to establish themselves in our bodies. And those are just some of the ways that our body protects itself. And, these are all three things working at the same time and working together.